you have starting the testing as and when the unit tests are being done by the developers. Now let's get into some kind of a technical insight into service virtualization. So I'm sure by now you might have understood a service virtualization is something like a stubbing. Okay, so stubbing is something like you have module 1 talking to module 2, tier 1 talking to tier 2, tier 2 talks to tier 3 or module 3. Now, all of a sudden, tier 3 is not present. What do you do? Traditionally, maybe so many years together, at a decade or 1.5 decades, we had been talking about writing a stub. But how were we creating the stubs? We need to get the entire source code of the developer, understand as to what is the tier, what kind of request does it get, what kind of response does it have to provide, and you have to start writing the code. Eventually, you will end up probably writing the same set of code a developer had written. Now, this one you cannot do as a testing engineer. So because most of the enterprises do not get access to the source code, and there is a testing only projects that you get as well. So now you as a software test engineer, how do you make a difference on virtue of creating stubs? So let's define what a service virtualization is. A service virtualization is a practice of simulating the behavior of a physical asset. So very clear understanding, or you can also say it's a virtual environment must behave enough like the physical environment to ensure the interactions with the emulated service look like a real one. So it's a pretty straightforward English statement. You can also have your own definition as and when we progress, but this is the kind of pretext or preface that I wanted to start with. Now let's move on. This will clearly tell us to what am I going to do as a part of service virtualization. I'm sure, look at this picture. I'm sure most of you as a software testing engineers, you all know what it is. People who have the experience in terms of QTPs or load runner or even any kind of sniffing tool, you know, if there is a client talking to a server, you know how to record that application. There are 2-3 ways that you record applications, like using automation or performance tools. Number one, we call it as a sniffer. Let's say a browser makes a call to web server, and you wanted the tool to capture all the requests made by the browser. So what happens is that particular tool can hook up with the browser session, which is iexplore.exe, for example, or firefox.exe, and it can start listening to what kind of request this browser makes. The another way is when there is a call happening between client and the server, you can hook up another machine in between, and we call it as a trapper. So this is a proxy mode of capturing the request. So this is something that you had been doing. An example is the JMeter, for example. So that is the performance testing tool. Incidentally, I think Selenium or any kind of test automation tool, we do not have a trapper way of capturing the request. So I'm sure I wanted to first tell you as to there is this is something that you had been doing. Now, with the similar kind of principle, how can you go ahead and create the stubs, right? So this is what I wanted to tell you. Now, you had always been capturing what is called as a request that goes from the client to the server. But had you been capturing the responses from the server to the client back? Now, let's say if you start capturing the responses from the server to the client back, now you have for this particular request, this is the response saved. And for this particular request, this response received. So I have those request response paths, and then just consolidate everything and make a wonderful stub out of it. Now, how different is this from the traditional 1.5 decade stubs? Traditionally, like I said, you need to have a source code, and you need to write a dummy HTML file or a dummy JSP file or a dummy servlet file or a dummy database and XML file, which would give me responses. So what I do with this kind of niche tools like niche tools of service virtualization is, you as a software testing had been capturing the request. Now all you have to do is capture the responses also, and pair up one request R1 with one response RSP, and then make a stub out of it. And this is exactly the principle of creating the stubs in the modern world. Now, Having said this principle is what we are going to do, what next? Look at the service virtualization in action. I'm talking about the existing environment, recording a service, and completely kicking out the dependent system and replacing that with a virtual service. So if you look at it, the client talks to the server, and let's say the server once talks to another server, which I call it as a dependent system. You all know that when a server talks to a server, it might not talk in a very understandable language. It would probably talk in XMLs or an object or a remote method invocation object. So what you're going to do is, you are not recording that between a client and server, but a server and another server. So in your first environment where you have a SOAP request going from server 1 to server 2, which is a dependent system, and the response coming, there's a SOAP response is coming, there's a JMS response is coming. Now you're hooking up in your second image virtual service recorder. All the requests and responses go via that particular solution. Now once that particular solution or tool captures the request response, the tool should have the power to just pair up the requests and responses and kick out the dependent systems and create a virtual service out of it. Now the client and server is retained, and the dependent systems are kicked out. Now if the dependent systems are not going to make any difference for functional testing, but you have system and the test ready there, then you can actually have the virtual service there, so that you need not worry about the dependent system, dependent systems availability. All right. So the SOAP request. Why did I put SOAP request? Was traditionally when the service virtualization was born, it was coming from a SOA systems, service-oriented architecture systems, mission to mission, B2B, business to business. So the calls that were actually happening to different web services, there was more need. There was a hunger for those kind of dependent systems to get virtualized, or those kind of systems not to impact the overall software testing schedule. Since the kind of hunger came from those kind of dependent systems, you see in this picture the SOAP request, SOAP response. But then it just need not be SOAP request. You can actually make a JDBC calls also to database, so those also can be virtualized very comfortably. So this picture will talk more also. Let me tell one more thing. Now, if you look at the system or this particular image, did I virtualize the system under test itself? Definitely not. If I actually completely virtualize system under test, then what are we testing for? So that's the question. So now, let's say you become a service virtualization developer, or you become a service virtualization practitioner. You need to understand which are the systems to be virtualized. You cannot completely entire application stack. You shouldn't completely virtualize that. Then you don't know what you are testing. You are just testing against the stuff. If there are dependent systems and those are the right candidates and those availability is a problem for you to continue the software testing, then those are the systems which are possible candidates for getting virtualized. So that is what this picture tells more, and I just proceed further. Now I'm going to talk about how are you going to virtualize once more. So look at this. There is a browser that makes a call to this web server. I make a HTTP URL. It's a HTTP request and a HTTP response. Now, like I told before, I'm going to hook up a tool in between, which means this particular tool I am not installing on the client. I'm just keeping another client in between, and I call it as a proxy. And all my requests, which are HTTP requests, I run through the proxy server, which means my proxy server will make the HTTP call on behalf of the client. And hence the proxy server also will get the response from the web server and send it back to the browser. So this is how the application flow. So I told this before, and I am actually now telling the technical words, which is proxy, port, browser, HTTP. And there's a tool in between, which means there are three missions here. One is the client, which has a browser, and another one is the tool, and another one is the web server. Now, if I create a virtual service, what should it do? That's the next question. I want to explain this into three. One, if you write a starboard, a virtual service, it has to listen to a request. Please understand, erstwhile you had been only capturing the request if you are doing an automation or performance or a SOA testing. Now you capture the request and you yourself as a software tester are responsible for sending the response also back. So typically your virtual service had to do predominantly three things. Number one, it has to listen. Number two, after listening to a request, it has to understand the request. It has to do some kind of processing. It need not process like how the developer has written the algorithm. You as a functional tester will know if I send a PNR, what kind of simple interest you have to get. It's very simple. You have to do P by N, PNR by 100. That's the simple interest you want to do. So that's the simple process you wanted to do. You send the request, and as a software testing engineer, you know what kind of response should come and how that response should have come. If the developer would have written the code, they need to declare the variables, they need to create a main class, they need to actually, compile that, and then do kind of isNumeric on quite some processing. But you can simply make this kind of process, and just not that algorithm. You can also do different kinds of processes like sending emails or printing reports or retrieve the score, bank credit score, like typically that happens in US, and getting a zip code for a state. You call a web services, and you need to pay for actually getting the zip code for various states. So now you need to process, and then you need to respond as well. So all these three are now getting into your responsibility and your accountability as a software testing engineer if you adopt the service virtualization. So this is what simply I can define the virtual service as. And now I'm going to a little more elaborate on the model of doing this, which is listen, process, respond. How does it boil down to? This is how it boils down. It listens to the request. It selects the response from VS image, which means virtual service image. Now I'm bringing a new keyword here, or a new technical word called VS image. Note this point, VSI otherwise. And it responds as well. But then before actually getting the request and then process, I'm actually customizing the request also, if you require, which is an optional step. And after selecting the response and sending the response to the browser back, I'm customizing the response also to suit the typical HTML. The client should not understand that the response is coming from some unknown server. So I'm customizing the response and then actually preparing and sending the response to the request, and I'm also audit tracking it. Now, two important terminologies I bring here. One is called the VS image, which is virtual service image. Assume that it is a database of request and response paths. The request gets matched up and the response gets selected. So that is VSI. Now on the heading, I'm seeing a typical virtual service model, which means a model in which the request comes in and the response goes out. So another keyword from there, which is VSM, virtual service model. So two keywords from this slide: virtual service image, database; virtual service model, the flow or orchestration. So those two are the takeaways from this slide. So that's how the virtual service model comes. Now let's look at the image. I said image is a database which contains request and response. Now let's see what does the request and response mean. Look at that. I said, let's say I want to create a new session or a login ID, and I actually invoke an object in a real world. So for this kind of object call, what do you do? How does a request come? Request comes like that. An XML which has login or password and a login name and password, and the response comes back like this. And if you want to probably withdraw money from an ATM, then how does a request and response come? So I am replacing the get new session Java servlet or an object with a request response pair like this. Now I don't want the Java object at all. So a combination of these request and the request response pairs comprises what is called a big database called as a VSI, virtual service image. And now I've also mentioned at the bottom right as this is stateless. That means when I'm withdrawing the money, I'm actually withdrawing from though I put it as account, there is no context maintained. But then if I have to maintain the context, then that becomes a stateful, and this is how it looks. The page is rendering. I'm waiting for that. Yeah. So when you log in, you get a new object. You call get new session, and then you sometimes you get the account and then withdraw money, or you directly withdraw money because the session is already created. So when you send a request call withdraw money, which particular point has to be fired? Whether it should be the one that is immediate or the one that is next to get account. So the selection of a right request response path, do you want it to maintain it as a stateful or stateless is a question. By the way, I might probably get confusing you on stateful, but if you do not understand the slide, that's no problem. So you need to understand just the virtual service image, which is a database of request response paths, which is what I wanted you to understand. And in case if you want to maintain a context, then you go to stateful from stateless, and where you maintain the complete flow also. So these are the two things that I wanted to give more important takeaways. Now let's look at a technical wordings of the service virtualization, which is request and response. Now in the request response pair, now let's discuss about the request itself. So when I make a request, for example, get the pin code of this particular state. That's the operation name. So when I actually ask for that, I need to send the state names. So I need to give a parameter value combination. For example, state name is equal to California. Country is equal to United States. So it has an operation name called, for example, the get pin code or get zip code, and the name and value combinations are arguments, like state is equal to California, country is equal to United States. So I'm sure you should be able to understand that particular positioning. Now, how does a response look like? A response will definitely have its body, and it might also have metadata, which is name value combination. So it's a pretty straightforward understanding. What does a request response mean? So this is what is going to be, like collection of all this is going to be in VSI, Virtual Service Image. One more depth I'm going to show. And I'm going to show in the context of one famous tool in service virtualization, which is CA Lisa, erstwhile called as ITCO Lisa. Now look at the request. So the request top, you need to see at top right, there's a request that we discussed. And you can see in the bottom, you can see the different request data that's been organized. I'll give you some time to observe as well. You have something called as attributes, you have something called metadata, and you have something called arguments. Let's say there is an operation called get user. For example, you need to get the details of a user. So you need to send the login information, right? For example, in this image, I send the login information. Login is equal to Dinesh. You can see that here. And on your bottom left, you see the attributes. If you are familiar with XML notation, you will understand what is attributes. So there could be some attributes going. And there is a metadata that is also going. Now, what does it mean to me? When there is a request coming to this virtual service or a stub, it will try to match the request with this. For example, the request comes saying that get me all the user details of login is equal to Dinesh. Now, if you would have created a virtual service to respond, login is equal to Dinesh, then it will respond. But I wanted a standard response for any get user information. For example, if it says login is equal to Uday, even then take this response and send back. In that case, my request should not have the Dinesh as hard-coded. Anyways, but Dinesh has been hard-coded, but I don't want to consider that. Then what you can do is there's something called magic string, and you check that box. So I am actually completely getting so faster on the Lisa, but I'm just telling about this is how typically the request that comes to the stubs are matched. So only when the request gets matched, I can now select the appropriate response. Now can we look at the response as well? Let's look at it. We discussed this response. Yeah, that's the response for you. And the response contains the body and the metadata, which is some set of HTTP header. Now closely observe the met body. It's nothing but the XML with all kind of nodes and all relevant nodes and the data against each and every XML node. So that's how the body would look like. And now what you can do is on your body, the left side you can see the XML nodes. On your right side you can see various recorded values. Now you can go there and you can change whatever you want. Now what kind of changes you can do? You can also link it up with a small Excel sheet which has a set of responses. You can also link it up with a Java or a Groovy script which can actually do some kind of action and respond. You can also link it up with some standard relational database systems like Oracle, MS SQL Server, whatever it is, and then get the appropriate response. Now, this is how it would look like. I explained conceptually how a request look like, how the scheme of request would look like, and I'm also explaining the concept and the schema of how a response should look like. So take a while. You need some time to understand. Now, what I have shown now is you had created a request response path. Now you call it as a virtual service. You have created a stub, and I'm sure you would appreciate that you have not known any coding written by the developer. You don't want any kind of jar files or library to create a stub. This is something that we have been following 1.5 decades. You don't think that a software tester should not be able to write a stub. So if you look at the request and response, and it's been very clearly tabulated, and you have a very good looking UI from this toolkit or solution, and you can just go and play around whatever responses that you want. But one thing you need to understand is you had been only capturing the request. Now you are also capturing responses for a good cost to keep responding for any particular request. At this moment, if there are any questions, and there seems to be a question tab, you can keep filing the questions. At the end, last 10 minutes, I'll be glad to answer it. Now I'm going to go a little faster. So there are 4 ways that you can trap all the request responses. One of the famous ways is what I had been discussing now. One is called proxy. There are point number 2, which is a proxy, or there are other ways. Technically, we call it as a gateway. Or what you can do is, I do not have the application itself ready, or the dependent system ready, the new one, but I don't know. So how can I capture the request? So look at the option number 3. If you have the request and response paths, you can easily create that from the scratch, the virtual service, which otherwise called as stubs. Otherwise, I lost my virtual service. I don't have anything with me, but the customer is ready to help, but he cannot host the application for me. Ask your customer to record the session and give the recorded session, and the tool should have the capability to convert it to a set of request response paths, thereby creating the stub. So these are the typical 4 ways of creating virtual asset. If you, and like I told, the proxy is the most famous way. Now, what I wanted to tell you is also that once you create the virtual services, the stubs, what you can do is you can deploy it on a server. So the blurred image on the top tells in the context of a CA Lisa, famous service virtualization tool. You can deploy that on one of the JBoss servers or a JT servers, and then it would exactly behave like another server itself. You can put it on a port, and that port is what you have to call for virtual service. And you can switch on and off between virtual and real. Morning, you have 2 hours of mainframe exposure window, so you can, for the 2 hours, you can have real environment, and the rest of the time, you can actually shift between virtual service. So that's what that particular tag says, and we have had quite some successes across various organizations. You can see where does it fit in. It had fit in a telecom provider in Australia. Then you had a local bank, which means banking BFSI domain using TIBCO Business Works in Singapore. and a retail domain as well in US. So if you look at the first 3 lines, it has covered the major domains, which is telecom, retail, and BFSI. Nevertheless, again, transportation domain and energy and utilities domains also we have covered. And now you can look at the solutions that have been used, CA Lisas, Parasoft Sovates, and you have IBM's, which was erstwhile called as a green hat. And you know SOAP UI is there, which is actually the SOAP UI is available for 30 days free, and then you have to purchase it. So that's quite cheaper, like somewhere around $350, $400. So that's more easy for you to create the virtual service tabs. Now, like I said, functional testing, where does it fit in, right? So I'm sure nowadays in Agile model, you have been doing what's called as a test-driven development, and you are more dependent on various small modules. So there are still companies, product-based companies, where they do a test-driven development, TDD. So those are the places where it fits in, the first set of places. I'll wait for the page to get rendered. Yes, the page got rendered. I'm very sorry. I'm completely out of my control about the speed. Okay. So test-driven development is a place where you can do parallel testing of various modules, and there's an MBT. The model-based testing at reality will come. Reality will become. It will become reality from there on. Erstwhile, you had been writing all the test cases. Now people wanted to create your models out of your application, and then from there create the test cases. All right. Now the middle tab is the second place where functional testing practitioners can look at. When you have been testing the component in between, you need to have a dependency on various systems. Developers are probably writing it, or developers are probably, still having things under progress. So you will have to definitely build virtual services for continuing the component testing. So with this, you also have a code coverage. So definitely things like component testing. With that, you as a testing engineer, you have a very good hands-on the code. What to say? People say white box testing, right? So you definitely will have hands-on on that. And the GUI automation or regression testing. Well, it's something like if you need to have develop the automation scripts, but the UI is ready, which means we call it as a wireframe, but the application in itself is not ready. So can I not have the UI working by just having the rest of the application stubbed up? Why do you need to do this? The UI is ready, so if I have something in the back end, I don't, as an automation test script developer, I'm not at this moment looking at the functionality. Rather, I'm looking at the GUI objects and etc. So I can probably create a stub and then start developing my automation scripts. So if I start developing my automation scripts, what happens is I'm ready when the actual application is ready, and I can start executing it. So I'm sure with this, the keyword-driven framework or automation framework, whatever you like, you can actually use it. So these are the 3 different things, places where functional testers, I have particularly seen there's the good benefits that are coming around. Now, let's look at some kind of Agile. Service Virtualization also has a good footprint on Agile. So I have to wait for the UI to render. Please bear with us. So you have seen sprint 1, 2, 3, 4, 5, 6, 7, and if you look at the the empty boxes without color, you can see there's a developed service, there. Now, if let's assume that this is how in a typical Agile model you have sprints coming out various speeds. Now, what do you do? Now, there's a wait time there in the first 1, 2, and 3, third sprint, and now that wait time, if you have to cut it down, you will have to virtualize. Now, when this particular enterprise application gets virtualized, how does it look? Hold on for a minute. The UI is rendering again. Yeah, that's how it looks. So instead of having the S2, you can actually create the stub for the S2 in the sprint 1 itself, and you can carry on the S1 testing, and then continue in sprint 3. You can have even the GUI tested with the S3 being a stub. Just because the S3 was not there until sprint 4, you had been having a waiting time on all sprint 1, 2, and 3, and now that gets replaced. I'm sure you will not be able to completely understand at the first shot. It takes a while for you to understand, and this is the actual diagram taken from the Agile development and Agile testing lifecycle. Now, when you virtualize it, what happens now is, hold on, the page is rendering. Look at that. When you now do the complete virtualization, now you can see the wait time goes off, and at the same time, there's so much of time that's saved starting from sprint 6 and 7. So with this virtual service developed, I can actually save lots of time in the whole of development and testing lifecycle. Of course, you can definitely have a good amount of debates around it. Can we do this? Can we do that? Can we do this? Can we do that? And etc. etc. But then, like I said, it's like I can give an analogy here. Look at this like a meditation class. Only when you believe this concept, you can definitely take it that in a right spirit, and then you can actually implement that in your workplace. Now, performance testing. For example, typically while you have been doing performance testing, you need to actually look at various different applications and various different tiers, and you need a third party, you need a mainframe. Assume that, let's take one example, a third party. Okay, in a third party, for example, if you're doing the e-commerce application testing. In an e-commerce application testing, you need to call a third party and for doing a payment. So when you make a payment, for every call that you call the third party, for example, PayPal. So when you call the third party guy, for every web services call, they're going to charge you. So if you wanted to do a performance testing at such a heavy load, you are definitely going to pay a lot. So what you can do is look at this diagram. You can see I have in my case, I have actually virtualized a database server. VTest is virtualized. I have actually virtualized the mainframe server, which is not available all the time. And I've also virtualized the credit card, which is the third-party call that they're going to make, that they're going to charge me for every call. So, but then did I actually virtualize my app server and web server? Not, because that's the main components of my performance testing, and I have decided very consciously that those two tiers should not be virtualized. So the decision is yours, and hence we request you to do a business value analysis. So that's about the various various service virtualization benefits and applicability. Now, you as a person, if you want to talk to, there are so many people